Hello everyone, welcome to Miss Lee's class. Today we're going to learn the Pythagorean relationships. Okay, so objective, discover a relationship among the side lengths of a right triangle. So when you have a right triangle has two sides that form the right angle. So those are two sides, and they are forming a right angle, and we call it legs. Those are two legs, and the third side of the right triangle is called hypotenuse. This is called hypotenuse. Okay, so hypotenuse always hypotenuse is facing the right angle, so it's opposite side of the right angle, right? So write it down. Hypotenuse facing the right angle. Okay, so let's draw three different right triangles. So I want you to pause the video and draw three different right triangles. Go ahead. Alright, let's do it together. So I'm going to draw a right angle, and it has two legs and hypotenuse, one hypotenuse. So this is the hypotenuse. And draw another triangle. Like this. This is the right angle, and here is the hypotenuse. And also I can draw this way. This is a right angle, and this is the hypotenuse. Okay, two legs and one hypotenuse. Okay, so right angles have a special property. This is really important. Okay, so let's figure out what the property is. Okay, so this is a right triangle because it has a right angle over here. Is this a right triangle? I don't see any right angle. To become a right triangle, it should have one right angle, but it doesn't have a right angle, right? So this is not a right triangle. So this is a right triangle. So let's compare those two triangles, okay? So each triangle has a square on each side, okay? So here, let's find out the side lengths. This is a 3, and this is a 4, and this is a 5. And let's find out the area of each square. Okay? So I want you to count the boxes. How many boxes do you have here? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So you have 16 boxes here. How many boxes do you have here? You have 9 boxes. And how many boxes do you have here? So count it. So if you count it, you have 25 boxes. So do you see any relationship between 16 and 9 and 25? So do you see any relationship between those two numbers? I see the relationship that adding 9 plus 16 becomes 25. Okay, let's see if this triangle has the same relationship. So this one is not a right triangle, but each side has a square. Okay, so this one, count it, 16. This one, count it, 16. And this one, if you count the number of boxes, it's 25. Do you see the same relationship? Is 16 plus 16 equals 25? No, it's not. It does not have that relationship. So only right triangle has this kind of relationship. Okay. If you draw a square on each side of the right triangle and add the area of two triangles on the legs, then that should be same as the area of the square on the hypotenuse. Okay? So basically, how did you find the 16? This 16, this is a 4. The length of this is a 4. You found 16 by squaring 4. How did you find 9? Same thing. You found 9 by squaring this number, 3. The 3 squared. Okay? How did you find 25? You squared 5. 5 squared. So therefore, 4 squared plus 3 squared. So 4 squared plus 3 squared is the same as 5 squared. Okay? Alright, then let's answer the question. Which triangle is a right triangle? Right or left? Right. Right triangle. Right one is the right triangle. What relationship do you see among the area of the square on the sides of the right triangle? So how could this relationship help you find the length of the side of a right triangle? So basically, everyone, the area of hypotenuse square, area of this square is same as, so area 1, this is leg 1. Leg 2. Okay? Or we say hypotenuse squared is the same as leg 1 squared plus leg 2 squared. Okay, let's move on. Okay, here's the summary. So the area of the square on the hypotenuse is 25. And the area of the square on the legs are 9 and 16. So when you add them up, 9 and 16, it becomes 25. So a similar relationship is true for all right triangles, not just this triangle. This applies to every single right triangle. All right? And we call that relationship the Pythagorean theorem. Okay? So we can use this relationship to find the length of any side of a right triangle. So when we know the length of the other two sides. Okay, so example 1. A triangle has a side length 5, 7, 9. So what are the area of 3 squares that can be drawn on the sides of the triangle? We don't really know if this is a right triangle or not. So let's draw a random triangle. So we are not sure if this is a right angle or not. So the longest side should be the hypotenuse, 7 and 5. Right? So let's find the area of each square. 9 squared is 81. Then 7 squared is 49. And 5 squared is 25. So those are the area of the square. So when you add those up, do you get 81? So when you add them up, 49 plus 25 equals 74, which is not 81. Therefore, it is not a right triangle because 49 plus 25 is not 81. So to become a right triangle, when you add those two, you have to get 81. All right. Example 2. Find the area of the square C. Right, we know the area of the squares attaching to two legs. And this is the hypotenuse. So when you solve this kind of problem, I always want you to highlight the hypotenuse. So remember, hypotenuse is the longest side facing the right angle, right? Okay, so 144, 25, add them up. What do you get? So 144 plus 25 is 169. So this is 169 square centimeter. So 169 square centimeter. So find the length of the side of the square C. So we know this is a 165. Then we are going to figure out the side length. How do you find the side length? That is square root of 169. What is the square root of 169? 169. To make 169, you have to repeat multiplying what number twice? 13. 13 squared, right? Now you can just cancel the square root. So therefore, the side length is 13. So it's 13 centimeter. What is the side length of this? So you have 25. What's root 25? That is 5. So what is the side length of this? What is square root of 144? That is 12 centimeter. Okay? All right, let's move on. So this question, how can you identify the hypotenuse of a right triangle? So what is the hypotenuse of a right triangle, everyone? I said it is facing the right angle. So I'm going to say the longest side facing the right angle. How can you use the Pythagorean theorem to find the length of a diagonal in a rectangle? Okay, everyone. This is a diagonal. And what kind of triangle is this? This is a right triangle. We can use this right triangle to find the hypotenuse of the diagonal in a rectangle. So hypotenuse is the diagonal of the rectangle. Make sense, everyone? Okay, let's move on. Okay, who is Pythagoras and what is Pythagoras most famous for? Okay, I want you to pause the video and using your cell phone or your computer, I want you to find who Pythagoras is and what is Pythagoras most famous for. Go ahead, everyone. All right, here's the answer. And I want you to think about number 2. What do we use the Pythagorean theorem in our real life? So I want you to pause the video again and think about how can we use the Pythagorean theorem in our real life. Go ahead, everyone. All right, everyone. When you use your cell phone, when you use your smartphone, the screen sizes are measured in diagonal length. So when we find the length of the diagonal, we use Pythagorean theorem. Okay? Because diagonal length is the square root of the sum of square of two adjacent sides, two legs, right? So when we say my phone is 4.5 inches, it means that the diagonal length is 4.5 inches. So we use diagonal length when we actually measure smartphone screens or computer screens or whatever. Okay? Alright everyone, so that is it for today. So now I want you to start doing your homework. Thanks for watching everyone. Bye bye.